you have done the work to create a seed bed with fire and Hack and Squirt, now it's time to evaluate and see how successful you were. A lot of landowners are fans of doing woods walks where they walk through their property and monitor the condition of the forest. But just walking randomly through the woods and pointing out that there are oak seedlings here, there, and everywhere just tells you that there are oak seedlings. It doesn't actually tell you how many oak seedlings there were. And in order to put a fine number on that and evaluate accurately the success of your operations, you need to do inventory plots, which you can use for basic statistics. You want to try to get enough inventory plots to be representative of your stand, which means you're always going to need at least 3 in order to draw an average. But I was always taught, basic rule of thumb, you want to try to do 16 inventory plots per 40. What we're going to do now is I'm going to enlist the help of Dr. Cunningham, and we're going to walk through setting up a 1/5 acre fixed radius plot with a 1/100th acre regen plot in the middle, and show you how to measure those. Loggers tape, you hold it at the center, and then you pull (52.8 feet. And then you put a flag at 52.8, and you put another flag at 11.9 feet for your 1/100th acre plot. Once you get your flag line drawn out, I like to do it in the 4 cardinals, 1 north, 1 east, south, and west. I've done a little bit heavier here so that we can see the outline of the plots more effectively. But once you get your 1/100th acre plot established, you want to count the regen first so that you don't trample it while you're measuring your overstory plot. Now this is one of those jobs in forestry that's really simple to do, but when a job is really simple to do, that usually means it's going to take forever to do it. And this is one of those where all it requires is counting all of the seedlings inside this 11.9 foot radius plot. And you just walk through and you count. 1, 2, 3, 4, 5, so on and so forth. There happen to be 9 oak seedlings in this plot. So because it's a 1/100th acre plot, you multiply 9 by 100 to get the oak seedlings per acre for this plot. Now that you know you've got 900 oak seedlings per acre for this plot, write it down, record it, and then we'll move on to the overstory. Once you get your reproduction plots finished and recorded, it's time to move on to your overstory plots. And for a 1/5 acre fixed radius overstory plot, you're going to measure every merchantable tree inside the 52.8 foot radius plot size. And to save time, I've already gone ahead and I've flagged in all of the trees on this plot which are in. There are 8 trees on this 1/5 acre plot. Once you get your trees flagged in and you know what you got to measure, it's time to do your measurements. The first and most important measurement that you're going to take on your tree is the diameter at breast height, which we typically refer to as DBH. And breast height is 4.5 feet off the ground. So you're going to measure the diameter of the tree at 4.5 feet off the ground. There are a number of different ways you can do such a thing. You can use the world's largest set of calipers and take measurements like this. But if you're using calipers, you're only measuring one diameter, and a tree may not be perfectly circular. So take 2 or 3 measurements per tree and then average them together to get the diameter of that tree. That can be skipped. Well, if you tear your microphone off, if you use a diameter tape. Our loggers tapes have a diameter side, a diameter reading side, or you can get an actual diameter tape from any one of a number of forestry suppliers on the internet. You just wrap your tape 4.5 feet at breast height and read your diameter measurement. It's an 18-inch tree. Because the tape form fits around the tree, you don't need to take more than 1 measurement. But the most common measuring device that we use for this is a Biltmore stick. I don't know about other states, but here in Arkansas, you can get one of these for free from your county extension agent. So go ahead and check. The way you use this, you sight it up on the tree, hold it at 25 inches from your eye, line up one side of the tree with one side of the stick, and then read the measurement on the other side. This one's saying a 17-inch tree. The Biltmore stick has the instructions on how to use it written on the stick. So it's really easy for somebody who's never used one to figure out what's going on. And once you get your diameter measured for your tree, record it, and move on to the next one. The way you use the Biltmore stick to measure the heights of your tree is you follow the instructions written on it, and you walk 66 feet away from the tree, hold the stick out at 25 inches, which is about arm's length for most people, sight the bottom of the stick with the top of the stump on the tree, and then read the scale up the stick to the first live branch on the tree, and that's going to be your merchantable height in 16-foot logs. Once you have your overstory plot data measured and recorded, and your reproduction plot data measured and recorded, it's time to go back to the house and do some math. One of the most useful measurements that can be derived from the data that you've taken is basal area. A measurement like trees per acre can tell you how many trees you have, but basal area tells you about the volume of each tree and allows us to compare different types of forest against one another. Imagine, if you will, a square acre, approximately 208 feet by 208 feet. On that square acre, there are trees growing, and if we take a cross-section of the forest at 4.5 foot off of the ground and look at it from the top, we will see the amount of that square acre that's occupied by woody stems. On a pine stand, you would see something regular and even. You could see a young hardwood stand with many small trees scattered over the acre, or you might find a mature hardwood stand dominated by a few extremely large trees. While the number of trees per acre can vary wildly depending upon the size of the trees, the basal area measurement is the same for all 3 of these examples. Regardless of what the cross-section looks like, you can take all of those areas occupied by those woody stems and condense them into a square inside the square acre. This is a great visual representation of basal area. The stand that we are currently working in has 90 square foot of basal area. So you draw a square with all 4 sides, a length of 90 foot inside your 208 by 208 foot acre. Now, if I told you that we wanted to harvest 10% of the trees in each of our previous examples, it would mean a different number for each example acre. If I said I wanted to harvest 10% of the trees per acre, the logger is going to get a lot more excited over the mature forest with the big plugs than with the pine plantation that has 10 and 12-inch trees. More value concentrated in fewer stems for the logger to have to cut and haul means more profitability for the logger. But if I told you that we wanted to harvest 10% of the volume in these stands, it would mean the same amount of merchantable material is being harvested in each example, allowing you to compare and contrast the different forest types. It's like having all of your fractions be the same denominator. So if we have a shelterwood prescription calling for a 90 basal area forest to be cut back to 50 basal area, it means we want to harvest 5,600 square foot of woody stems out of the 8,100 square foot available, leaving about 30% of the stand's volume, or 8 trees in the mature forest example, and 25 of the smaller pine trees in the first example. In order to calculate basal area, you first take the diameter that you recorded, square it, and then multiply by the number 0.005454, which is called the Forester's constant, and is used to turn the diameter into square footage. When you do that, you get a small number for each tree. When you add them all together and then multiply by the plot size, you get the basal area per plot. So for like a 1/5 acre plot, once you calculate the basal area of every tree, you multiply by 5. You do this for every plot that you measured, and then average the basal areas across all the plots for the stand's average basal area. The same goes with your reproduction plots. Once you have all of your plots counted up, you multiply the number of trees by 100, and then you average all of those numbers together across the stand to get the stand's average reproduction.